thank you. Hello, Fosdem. It's great to be here again. I've been at this dev room in the last few years. It's sort of my favorite conference, but don't tell to the other conferences because otherwise they'll be upset. So I tried to do as lightly. No, this is not working. Here. Maybe. Do I have to do it manually? I'll go on. Okay, this is interesting. My slides just won't move on. I can go full screen. Okay, now we will move on. Good job. Okay, so I wanted to give a slightly different talk. So all of you know what is Ganeti perfectly. How many people don't know? Just a couple? Okay. So instead of introducing Ganeti fully as I did usually, I'll introduce it in one slide and then move on to strange features and things that you hopefully haven't heard about. So what's Ganeti? It's a software stack we developed at Google in the last 5-6 years. It allows you to manage clusters of 1 to about 200 virtual machines, bit more, bit less, depending on your infrastructure. If you want more, you'll have to install more Ganeti clusters and have an infrastructure on top. The GRNet guys have made such an infrastructure and presented it yesterday, and there's other options as well. You can create your homegrown infrastructure or something like that. You can use Xen or KVM, LXC if you feel brave, and it supports like live migration, resiliency to failure with or without dedicated shared storage in hardware, DRBD or Ceph if you want it in software. It allows you to rebalance the cluster. It has an easy way to swap hardware and repair it so that you don't depend on any single hardware, and we treat all the nodes as equal. That said, you can control Ganeti via command line, a RESTful interface, so you can write your own software, or some people have written web interfaces for it. Now you know what's Ganeti. So how many people don't know what's Ganeti? Nobody, good. So let's go to features that we've added more recently, or that even if they've been there for a while, you probably haven't heard of. One of them is the monitoring daemon. We've added this, I think, in 2.8. 2.8 was released sometime this year. I don't remember when. So how do you monitor a Ganeti cluster? You have a monitoring system, right? That is hopefully the same for all of your organization. We don't have one that we give it to you because Google has its own monitoring system that has been written by other people that are not as friendly as us, clearly. Just joking. So basically there's a monitoring system, and you have to control all the various parts of how the cluster behaves. So there's the cluster itself, like is it healthy, does it think that you're N+1 compliant, all these sort of things. Then you have to control the storage, you have to control the single nodes, whether they are up, the DRBDs in case you use DRBD, are the instances up or down, all these sort of things. And which means that you have to write a lot of rules that control inside your cluster. With the monitoring daemon, we just give you one single point on each node though, on which you can control the cluster. So the monitoring daemon exports data in JSON format, and then you query it from your monitoring system, and when the monitoring daemon says something is wrong, and you go repair it. So you call your hardware people and you say, go replace me that node because it doesn't work. So it gives you information about the health and the state of the cluster. The state is general things that are happening, whether or not they're bad, and the health is, are things okay or not? It gives you very live information, like as up to date as possible, and it gives you exclusively read-only information. You can't do anything on it. There's a design document which you can read about what we were thinking when we were implementing it in case you think it was completely crazy, and you can go back to that. So it's an HTTP daemon. It has only GET queries actually, and it gives you replies in JSON. It runs on every mode, or on every node, because of course you want to control what's going on in real time, and gathering all the data in a single point is more complicated. Yes? Hi. Data collectors. So inside the monitoring daemon, there are these smaller data collectors that provide you data on the various aspects. So there's data collectors for storage, the hypervisors, the various Ganeti daemons, the instances, and there are some that report on performance, So how much your node is loaded and things that might or might not be bad depending on your situation. And then there are the status, like is this node up or down? Is this instance up or down? Which is, when it's down, definitely bad. And then there's some data collectors that are stateful, which means that remember some history, while normal ones like is this up or down are only about the last moment. So you can read, for example, instance status for Xen. I think KVM is coming into 10 to 11. The GRNet people should have more information about that. Information about the storage, information about the backend for the storage. So in that case, it's like the general disk and the backend of the disk. DRBD, in case you're using DRBD, is it in sync, is it out of sync, what's going on? And the load average for the CPU. You can easily write more data collectors in Haskell, or there was supposed to be a small plugin interface. I hope we did that. Did we do that? So this is the report format. I'm not going to go through all fields, but I put it here so that you can go back to my slides, which will be on the Ganeti webpage afterwards, and you can go and see what the various fields mean. And then, of course, in this way, you can write your software to integrate with it and say, OK, this means good, this means bad, and this is when I need to be woken up at night and go fix my cluster, which is an unfortunate situation. You don't want to be that. Status reporting are the data collectors that report on the status of the cluster, while there's the ones that just give you values but don't have a particular how broken it is, right? We don't know how broken it is if your disk is getting full, but we definitely know that if the master is not responsive, then it's broken, and hopefully there will be information about that. So just query the daemon via HTTP. It's not authenticated, it's read-only. Just put it on a private interface, firewall it, we don't care. Disable it if you don't need it, but try to not leave it open to the world. Then basically you can go and check which collectors you have, and then see either all collectors or query one collector in specific, depending on how your monitoring system needs information. And you just point it at all nodes, gather information, and then do your own number crunching and statistics. That's it. So now, configuration daemon, confd. While the monitoring daemon answered the question, what's going on in the cluster right now, the confd answers the questions, how are things supposed to be, right? Sometimes you know, and hopefully you do, but sometimes you don't. Maybe there was an internal rebalance or things like that, so how do you figure it out? Before confd, you had to ask the master via RAPI. This, by the way, confd is there since 2.1 or so you can use it on basically any Ganeti version. If you're still using before 2.1, please upgrade, like yesterday. Is anybody using Ganeti 1.2 again? Still? No? Victory, we got rid of legacy version. So, you had to ask the master candidates for information about what's inside your config data, basically, or you could read it from the master or from the master candidates, but it was a bit complicated. Either you parse config data manually or you have to ask via API, but if the master goes down, then you lose that kind of information. Now, the master being down is already bad enough, but sometimes you still want to know which instances where, even if you're going on and replacing the master in the meantime. I mean, if the master is down, okay, maybe you can't migrate instances or you can't create a new one, but you still have a lot of instances that are up and that you want information about. So how do you do that? You use confd. There are also values on each node replicated with ssconf, but these are, we can't replicate everything, basically. And so we need a way that was scalable and had no single point of failure to access this other data. So there's this information in config data. We give it to you read-only, as usual. We like read-only because it's easier. And it's completely distributed. So you ask all master candidates, and it will provide you information about, well, ping is just, are you alive? What the master IP is in case you lost track of where your master was. And then you want to go to it and do like any sort of query or other things. The role of a node, is it master, is it offline, is it online, what's going on? What's the primary IP of a node? what are all the secondary, all the primary IPs or master candidates. This is a very interesting query because confd libraries itself use these to update the master candidates. So even if they lost track and you offlined a couple of nodes and then you promoted another couple of nodes, as long as they know of at least some master candidates that still exist, they can figure out the new version, the new list, and stick with the working configuration. And then what are the instances IPs? Where's the node primary, the DRB minors, and which instances are on each node? You can easily implement more queries for confd, but right now this is what it provides. And it's a UDP protocol. It's authenticated with HMAC, so you need to know a shared secret with the cluster before you can query confd, because maybe you have private data there and you don't want to share it with the world. But it's not encrypted, so either you use IPsec or something else, or you just know that people cannot query your cluster at random, but they can still read the answers if they can read on your wire, which is still better because not everybody can read on your wire, I hope. And then there's a timestamp in the HMAC so that people cannot do replay attacks too much and so on. It also covers the IP from source, so they can't like reroute the direction and so on. And how does the protocol work? So you have your client, and you send the request to a bunch of master candidates. This is UDP. Some of them will get lost. Some replies will get lost. Some master candidates will be offline. You don't care. You don't need to wait. You don't have timeout. You don't have any sort of problem with TCP. And then some of them will reply, like just 3 of them out of all the ones you sent. Maybe you have 20 master candidates. You send about 5, and you hope that some reply. And the reply contains a version so that you can wait until you get enough replies, let's say 3 out of 6, something like that, something reasonable, and then just grab the newest one in case there was an update going on in the meantime, and you have hopefully up-to-date information. As you do the query more, you should get more and more up-to-date information. And this is the protocol, how it works. Again, I'm not going to go through all the fields, but you can go back to the slides and have a look at it, and also to the design doc, man pages, and so on. And this is the reply to the protocol before. And these are all the explanations and so on. So there are clients that you can use so that you don't need to write your confd UDP protocol. There's one client in Python and one in Haskell. If you need another language, go ahead. If you contribute a client, we'll probably integrate it there, or you can tell us where it is. But I mean, hey, you have Haskell there. Houston would be proud of you if you tried to use that one. So not a lot of queries are supported, but there are quite enough. If you need more, let us know. If you start using confd and you're interested, just let us know. Right now, we use confd from the monitoring daemon to get information from the nodes that we need to get fast, and we can't ask to the master, but there might be other uses. And that's it for confd. Now I'm passing to 2 topics that were contributed by GRNet, our partner in Greece. So if GRNet people want to interrupt me and say that I'm telling this all wrong, I'm sorry. But yes, so also these slides are borrowed in part from Dimitris. So currently, to define how a virtual machine connects to the network, you give it a MAC address, which is usually inside the same prefix, and it's usually sort of randomly generated. An IP address, if you want, that's optional. A link, which is usually a bridge you connect your NIC to, and a mode, which is bridged or routed. Most of the time it's routed, right? It's bridged, sorry. And so normally when you use mode bridge, it basically just adds your interface to the bridge nominated by your link, right? And that's an easy way. You can connect machines to almost anything this way, right? But that's not enough, right? You can easily get it wrong. You can put some wrong value in a link. How do you figure it out? And for example, how do you know which machines are all in the same collision domain? Well, you need to go query and then see which ones do have the same link. It's a bit more complicated. Even harder, how do you know when you want to have your new machine which IP you want to use? Now, we didn't have this functionality, because at Google we have a giant machine database somewhere in the belly of Google that just gives us IPs when we need them. Okay, no, let's not go into the details of this because that would make me cry. But yeah, so luckily the GRNet people didn't have this solution, and so they implemented a native one in Ganeti. So they implemented GNT network. GNT network basically says which collision domain are your machines on, right? So first you create a network, and then you say, when you create a machine, actually when you create a NIC, this NIC is on network X. And also the network support an IP pool, so that if you specify that a machine has an IP, it gets held in the pool, and if you don't know and you say auto, the pool will just grab a free IP and give it to you. And you can also support reservations saying, these ones are reserved for my network people, and so don't ever give those away because they're not to be used inside Ganeti. So the existing per NIC flexibility is there. You can still configure your NIC manually, but if you don't want to, this helps you hide what's underneath and sort of abstract it a bit more. So GNT network is just a tool on top of config data, right? So it just basically has this IP pool structure, and for the rest it just keeps your NIC parameters collapsed per network name, but it's just a layer of indirection. Instead, if you need to actually make these machines behave differently depending on the network, you still need to use hooks and other tools. And the GRNet people have also written some of these tools, which I'm going to go through now. So there are these external scripts that they provide, which are SNF network and NFDHCPD. How about a better name for that? I don't know. GNT-DHCP, I don't know. Anyway. And yep. So SNF network is what basically at the node level connects these machines to the networks and supports a bit more than the default KVM, IFAP, or VIF Ganeti. And then it uses NFDHCPD to actually help you give the machine the actual real IP. And this provides you a bit more, like, as you see, it allows you to, for example, update DNS automatically in case you have a DNS server that needs to be updated when a new machine is created, and things like that. NFDHCPD is based on FNFQ, so you create an IP table rules, and you put on another queue your DHCP requests from the instance, and this goes to this user space daemon that then can reply to the instance without you needing to have a real DHCP server answering on that network. This is useful because this way you have a DHCP server on each node rather than one centralized one on the network. And this is more scalable because your DNS server can never go down unless all your machines on that node go down at the same time, unless the process crashes. But I suppose it doesn't, right? It's bug-free. Anyway. So yeah, this is how it works. And when this is an example, you can just add a new network, specify which IP range you use, what's the gateway, and so on, and this will be passed then via NFDHCPD to the instance, right? If you tag it with NFDHCPD, then it will be actually sent using NFDHCPD, otherwise not. And then you connect the network to a node group, because in each node group you might have a network on a different VLAN. Suppose the node groups are in different data centers where the same VLAN is visible on different numbers because your network people want to harm you, then that's a way to get back to them. And yeah. So then you can create an instance and tell it, well, this is the network of that NIC, right? And you don't need to specify anything anymore because it will know, depending on the node group, which bridge to connect it to. And if you migrate the instance from one node group to the other, it will have the up-to-date information, and your life will be completely stress-free from this point of view. You'll have plenty of other stresses, right? Okay. Okay, and then it's easy. And then you can also query like the information about the instance and the information about the network to see what's going on. With the SNF scripts, you install those, you put the IP table rules that I told you about before, and then things magically work when you reboot your instance, then the instance gets the right IP, gets the right gateway, and everything from an NFDHCPD and SNF network that work together for this work. And you can have a look at then SNF network code, and then SNF THCPD Git repository to know more about it. They're also packaged for Debian, so you can just download them with apt-get, as I was saying. How are you doing with time? Just to know if I'm too fast. Not too bad, not too bad. Finally, X storage interface, also contributed by GRNet. Also thanks for Konstantinos for some of these slides. So before X storage, we just had inside Ganeti disk types, right? So we had plain, we had file, which are just LVM disks and file disks. We had the RBD, which was your way not to have a NAS. And then we had shared file in case you had a directory exported to all machines. RBD for Ceph, block dev, and diskless. But what if you have an actual NAS, right? The Debian people, for example, have NASs because they sort of got them for free. They tend to get all these donations. And then what we were doing is they were using block dev, creating the volume manually on the NAS, exporting it manually on the node, and then associating the instance on the block dev. And this doesn't scale at all, because when you need to migrate the instance, you need to manually move the volume, and this is a huge nightmare, and I don't know how they survived it. So luckily, the GRNet people had the same problem, but also had a lot of time and developers and money from Germany. Anyway, no, just joking. And so they created this interface that you can use to connect your NAS. Now the problem with SANs and NAS is that they're all different, right? So you might use NetApp, you might use ABM, you might use something else. So what do? Well, you just basically create a bunch of scripts in your favorite language. So if you're a normal system administrator, you use Bash. If you're used to use Haskell. And then you basically connect this script to your NAS, and you make it act for it. So this is done with the X storage interface. With the X storage interface, you create a provider for your NAS. For example, NetApp if you have a NetApp, or IBM if you have an IBM, just not to make too much sponsorship for people that maybe don't even sponsor this conference. I don't know. Anyway, in reality, just use the RBD and open source solutions. Don't use this stuff. But if you really have it, right? So every provider provides methods that basically talk to your backend storage and do things on it. So there must be a way to create a disk on the backend appliance, remove, grow a disk, attach a disk to a node, detach it, add any metadata, and verify the provider itself supported parameter in case you have an extra parameter that says something else. For example, which actual backend to use among a set of 5 that use the same hardware and so the same provider, right? So how does a provider actually look like? Well, you just have executables for all those actions. And then there are some type of behavior that are expected, and some type of returns, and some type of environment variable that we pass to your script in order for you to be able to know what's going on. So once you implement those scripts that talk to your backend storage, then you won. You're sorted, right? So at that point, you can use the template X, add the option which provider in X you're using, like is it the IBM or NetApp or what NAS you're using, and then you use it this way, right? So just specify the provider and everything works, or you can specify also, and then everything works magically, right? You can modify the disk, add one disk, remove one disk, grow it, and so on. You can do migrations, and everything works behind the scenes with the scripts you implemented. Finally, your provider, as I said, supports extra parameters. So those parameters must be verified by the verify scripts, and then they can be used in any arbitrary way, which we don't know about because we don't know what your provider is actually doing. And then those parameters get exported as environment variables. So with GNT storage, you get a way to diagnose your backend storages, and you get a way to do to get information about them. And these are the man pages and the design doc, which we argued a lot about before accepting the current implementation. So clearly now it's there. Thank you very much. Are there any questions? Yes.
So the external storage interface is quite cool, and I wrote my own interface, and it's probably good. But is there a place to share such interface implementations besides the Google Ganeti mailing list?
So we plan to have a wiki page, and probably Konstantinos will be the maintainer of the list, so just send it to him and we can put it there. Also, if it's good enough and you're confident that it's a great idea, just ship it and we'll put it in the tarball for you in the examples directory. So that's a good way. If you don't feel like signing the CLA, all this evil stuff, put it on your website, ask Konstantinos, and we'll try to put it on the wiki. Yes?
How much has changed with the LXC integration since 2.7?
Since 2.7, I think not much. I don't remember in which version. Phaidon made some patches and some fixes, but yeah, I don't remember if it's 2.7 or 2.8. Did you have problems with it? Are you trying on it? Or?
Well, I had some problems with, tried it just short, not really following the problems then, because just set up one test installation and well, it failed when I wanted to stop the instance. It gave me then an error up, and yeah.
Yeah, probably it couldn't actually stop it in a meaningful way.
The command failed somehow. Tried it then with LXC was stopped directly, and it gave me some kind of error with it can't write to the file and the name from this.
So this is about problems with LXC. LXC is not perfect yet. I don't even know if the final container implementation will look like via LXC or something else. But yeah, if you feel like working on it and fixing it, we accept patches, but we don't run it in production right now. So it's a bit harder to, and like there's various versions that have changed quite a bit. So I don't know. Maybe at some point, if nobody is interested, we'll remove it, or if someone wants to take care of it, we can try to update it. Anybody else? Him first, go on.
With Ganeti network, is it possible to hook into it to do extra steps when adding or removing an IP? Say my network people love me and they give me IPs, but I have to ask for them over one protocol or another?
Yep, there are hooks. So you can definitely do that. Any more? Sir again, go ahead.
How much has been done now with the network, GT implements network for IPv6 only networks?
So there is definitely support for both IPv4 and IPv6. IPv6 doesn't have the pool implementation as far as I remember, but the rest should work. Like you could, right?
But you can only say set up a dual stack network, not only IPv6 network as far as I know. If I'm still up to date on that.
Okay, I don't remember right now. So in case, feel free to send patches. We're happy to have IPv6 only network. Or, I mean, to be fair, you could specify a fake IP address and then in your scripts not pass the IP. But of course, it would be great if GNT network could support it directly. Yes?
If I may comment on it.
Yep.
That's what we do with Cinephone. Just if you have an IPv6 only network, just pass a dummy IPv4 network, and that's it.
Yeah, go on. Send the patch. Don't be lazy. Send the patch. Don't be lazy.
Or even committing a patch for that. Yeah, exactly.
Okay.
You could be committed, submitting a patch soon, exactly for that.
Okay, so 212. Dimara has promised. Anybody else? More questions? No. How's time? So we have 10 minutes more, but if there are no more questions, you can go for coffee. No, there's a question. Sorry, no coffee.
Perhaps you can say some few sentences regarding auto repair and the pacemaker.
Yes, so auto repair and the pacemaker integration. There is an experimental pacemaker integration in Ganeti. You're welcome to try it and see what's broken and what's functional. We're also not using it, but when I implemented it, it was sort of working. And that's just for the master node failover and the nodes offlining and onlining. Then from that, the auto repair picks on. So as long as your master is working, which this integration should guarantee for you. Then there's this HA rep, which is one of the H tools. You just put it in cron tab, and you specify on your cluster that you want auto repair, and this will be able to do some basic repairs on your cluster. So if a node is seen as offline, which again the pacemaker integration will do if the node doesn't reply to pacemaker, then the auto repair picks up and can like fail over the instance since the node is offline, so you can't live migrate it anymore, and fix the DRBD, migrate the data, and so on. So this is how they integrate with each other. Try it out and let us know what's broken.
There's a limitation I heard from about 40 nodes in the pacemaker. Does it apply also to Ganeti?
I don't know. I implemented it on pacemaker as it was, but I didn't check about pacemaker limitations. If there is, then don't use pacemaker and find another way to just do two things, which, well, I mean, you won't have more than 40 master candidates, so that's fine for the master candidates and the master failover. You just have to find a way in your monitoring system to say, if a node is down, offline it, and then the auto repair takes over, right? So it shouldn't be that hard. We don't want to do it inside Ganeti because it's the cluster having a view of itself, and we'd rather you, for example, make sure of the fact that the node is down. So for example, switch off electricity if you can, switch off the network port so that if it doesn't respond, it won't come up all of a sudden and try to make things more complicated. Thank you. Yes?
How good is the implementation of the virtual switch infrastructure, the open reswitch? So
Oh,
does it work?
perfect.
Did you test it?
We tested it, it works, it's very simple. So at least the initial one was just using the OpenVSwitch command rather than the other command, and then you have to do manually things on your OpenVSwitch. It's not that hard to get, so it's hard to get it wrong, really.
Okay, but is there an easy way to migrate from the old bridged way with all these interfaces and stuff like that to go to
That's interesting. So
cluster to the open switch?
I think the best way for you to do that would be to set a new node group with OpenVSwitch, and then or even some nodes with OpenVSwitch, then set the instances to OpenVSwitch and then migrate them to those nodes. But basically, if you reboot in the meantime an instance on a node that is not OpenVSwitch, it's a bit ugly. So do it instance by instance, like set OpenVSwitch, migrate, set OpenVSwitch, migrate, and this should work. This works well with, OpenVSwitch works well with KVM. For Xen, you might have to replace and use the VIF Ganeti instead of their standard VIF tool, because otherwise that costs BRCTL. Yes?
You said
4 minutes, yeah.
you're running you can add up to 200 nodes to one cluster. I wanted to ask how exactly should the network be built in that case? Because DRBD uses quite a lot of traffic if you draw I/O attached.
So how should the network be built if you have 200 nodes of one cluster? What we do actually is we have a separate replication network on a separate VLAN that spans the cluster. Then we have the nodes each in a separate node group, and all of it is in a separate network. So all the nodes are in a network, the instances are on its own VLAN that spans the clusters, and the replication is in its own VLAN as well.
10 gigabit Ethernet or normal 1 gigabit?
No, 10 gigabit, come on, don't be cheap.
Didn't understand, sorry.
I said 10 gigabit, don't be cheap.
So he says, go with 10 gigabits.
If you can, I mean, hey.
Yeah, it's a bit difficult, the switches are a bit expensive.
Then maybe try to, I mean, if it doesn't scale, try to build separate clusters with separate replications, or you can even have in the same cluster 2 different replications. You just can't do live migration, then you have a different way to move. You have to use GNC instance move to move from one node group to the other then. And I think that's sort of it. Thank you very much. It was great to be here. See you next year, I hope.